Perform the indicated operation on the polynomials and simplify your answers completely. So we have this first polynomial subtracting the second polynomial. One way to think of it is like there's a -1 on the outside that needs to be distributed in. What this negative sign is going to do is it's going to change every single sign on the inside. And so I'm going to rewrite it, but I'm going to rewrite it under this first one. So -1 times -5x to the fifth will get a positive 5x to the fifth. We'll even put plus there. -1 times positive 10x squared will give us a negative 10x squared. -1 times positive 4 will give us a -4. I'm actually going to put this over here just so we don't combine it with the 3x because it's not a like term. Now let's do a quick check. Notice each sign changed. It was -5x to the fifth, now it's positive. It was a positive 10x, now it's a negative 10x squared. It's a positive 4, now it's a -4. And I'm going to cross this out. So combine these, -3 plus 5, we get a positive 2x to the fifth. -6 minus 10, we get a -16x squared. Plus 3x, there was nothing to combine there, and minus 4. Notice the exponents are not changing. So it's like we're adding up how many x to the fifths we have. We're adding up how many x squareds. Only when you multiply do those exponents change, but here they have to be like terms to combine and the exponents do not change. This will be the final answer there. And if that was confusing, you could even write out the -3x to the fifth minus 6x squared plus 3x separate, because I think that was a little confusing to have it right there. And then add the 5x to the fifth minus 10x squared and then minus 4 over here. I feel like that's a little bit more clear so it's not getting mixed up with the old equation.